Peace. Guess who I have in the house today? Mr. Peter Zila. Thank you, sir, for stopping by. I'm looking forward to this.
Thank you for inviting me.
This is going to be a wealth of knowledge unleashed, isn't it?
Maybe.
Welcome to Let's Weld Something. I'm your host, Bob Moffatt. Peter Zila today. We've got some high power aluminum applications, your forte, right?
Yeah, I'm doing okay with aluminum.
I think you are. That's why. Got your HTP machines, the programs, the pulse on pulse, and all the advanced settings. We're going to talk about some aluminum applications and surface prep and all that good stuff, right?
Absolutely.
Looking forward to it. Let's
like shining light on it or just spreading more misinformation.
I'll put some goobers on here. Yeah. All right, let's get to it. HTP Pro Pulse 220. You wrote the programs and everything, right?
I wouldn't go that far, but yes, I was involved somehow in some of the design features.
Okay. So we have aluminum on here, pure argon. We want to do some sample welds. We want to talk about everything aluminum, everything pulse and the advantages and all that kind of stuff. We'll do simple fillet welds. We'll do some lap welds. We'll talk about the heat input, start to finish, travel, all that kind of stuff. Push versus pull, what happens?
No. Push, no pull.
Push, but we're gonna...
And always vertical up, never vertical down.
Right, all right. I've seen folks do that before. There's times I've had to.
Well, if the gun angle is steep enough and you're flying fast enough, maybe.
Yeah.
But no, generally always vertical up and always push on aluminum.
Fun. Hey, if you have to go, if it has to be there, grab the stick welding, right?
Yes, aluminum stick welding rod.
We like that stuff.
We like that stuff,
man,
yes.
I cringe, but I wasn't going to give up. I did some more welds with it. Came out pretty nice. So, all right, first things we want to do here. Pro Pulse 220. And for aluminum, are we have to go to a program right away? Or
well, if you want pulse, you do. Like you have a manual mode. Right there.
Manual aluminum?
Manual anything.
Can we do that?
Sure, we could. Just spray arc it manually.
I think we should. And then go into the pulse.
You have your wire feed on one knob. You have your voltage on the other knob, just like a classic MIG machine. Okay. And you can dial in whatever parameters you want and just manually wing it.
Is,
I believe it's...
What was that?
035.
035.
4043 035.
I'm guessing 20.5 volts. That's...
Should we go with your guess? We have extra tips.
Oh, that was hard. 21.5. 21.5, and I'm not sure on the wire feed speed. I'm going to say I'll say 250.
Well,
is that low? Oh, you have an app?
Maybe. No, I don't have an app. But what we did, look, what happened with this machine is this side was left blank intentionally.
I saw that.
Back in the days, people had a door chart. And then all the door chart was electronically programmed into the machine, into the programs. Okay. But there's always the one guy who says, I'd rather dial it in myself. So, and then they don't know where to start. So we ended up designing a door chart for it. It's going to look just like that. It's going to go right here.
Hold still, and we'll see how close it was. We're going to do...
Hold on here. 4043 is this one here. 100% argon, 035. And we're going to do 1/8 inches here. 17.5 volts, 360 inches a minute.
I was way off. I think I would have burned a contact tip.
Maybe.
250, that's a shine off from 360 there.
And at 20.5 volts, you may have burned a contact tip.
I'm thinking I would have. So 17, what was that, 17.8? 17?
17.7 at 360.
We'll see how close you are. Probably right on the money. I'll go 17.8, 362. How about that?
All right.
All right, so... next up, we're getting ready to weld some aluminum. We're at 1/8 inch. I'm gonna grab some samples here. So I'm getting these burrs off of here. Let's go ahead and set up and pull the trigger on 17.8, 362.
And see how that works for 1/8 inch material.
Weld and not burn up contact tips like I would have. Getting better. I mean, No, that was interesting stuff right there.
Eighth-inch material is about the thinnest you want to do, really.
Because of that heat racing forward and
with just like MIG with no pulse. You go any lower, you're getting that popping and crackle, that short circuit. You're not really get a good spray arc on thin material.
I felt like I was waiting on it to begin with and then rushing at the end.
Yes,
And
so, well, you'd be rushing on the end even more.
Right.
But here, so if I pick another setting...
I want to go up just a little bit. I want to go like 18,
hold on.
18.1 and...
Let me tell you,
375.
So the one we did for 3/16ths, for example, is 400 inches a minute and 19.9. So you go up from 360 to 400, and you go up from 17.8 to 19.9.
That's substantial.
Well, then go less, 19.2.
Well,
3.
yeah, but still, that's up quite a bit.
Well, that should help you with more spray and less globular.
Right. So, now if I weld on the back side of this...
Well, by the time it's cool and we talk long enough, you can just weld on the back side of it.
Right, but also have that mass.
Yeah, but it's still going to be a little bit warm, too.
Okay.
See, the other material was like, what, 65 here in the warehouse? This is probably still about 130. So, but you have some mass, but you have some heat. If it's a little bit mass and a little bit heat, that weld is not all that big to begin with. I mean, it's a skinny bead there.
Okay. To me, I felt like I didn't have to race near as much down here at this end because I started out and went faster to begin with, so the heat didn't get out ahead of me. That's just my thoughts on that one.
Yeah.
And I see that I missed a little bit in profile. I'm down too far on that one, but.
Well, and another volt up, you probably wouldn't have had much crackling at all.
But on 1/8 inch, I'd take it on 1/8 inch, for control. But I agree, yeah, another volt up, and I'd probably get across that transition to spray. I should have waited.
Yeah.
Because that's like cupped out.
That's when it happens when you don't change your settings and you you change the heat on the part.
Right. So it was heat soaked. I mean, the profile on that is like unacceptably weak. There's nothing there hardly. So I should have dropped that in the Coupon cooler then, huh?
In the Coupon cooler, yeah.
Coupon cooler.
You have a bucket with H2O, it's your Coupon cooler.
That's right.
And then flip it over on the bottom and how it bled through. I guarantee you.
You think it got through?
Yeah, big time.
How much you'll bet?
10.
Pay me.
Okay, I'll pay you.
No, I'm joking. I'm joking.
Well, then you had a very thick plate on the bottom here.
Yeah. Well, this was that
really
little bit of heat sink.
It's a little bit through.
Got it right there.
Got it right there a little bit.
Started to get the discoloration.
Okay, we're gonna call this a tie.
Okay. All right, but still, we admit that the first weld better.
The first weld was better, and the second one was the one that bled through on this side. This one did not. Flip it back. See, here's where it bled through on the second one on the bottom.
Yep.
The top one did not bleed through.
Yeah.
Well, I guess pay me. No, I'm just good. It's not much.
You said horribly.
I thought it was horribly. Yes.
Horribly. Okay. That's where I'm getting all of it.
That's where you're getting out. It bled through, but not horribly.
All right. So, but again, that's the things that we need to be aware of right there. What's happening with aluminum? It dissipates heat 4 times faster than carbon steel.
Yeah, it
races through there.
Yes, it transfers the heat. That's the problem. So these little pieces, they heat up like crazy too. But can you weld on like a 15, 18-foot long aluminum boat, all aluminum hull, all aluminum stiffeners in there, all aluminum everything. The moment you weld on there, the heat is being sucked out, distributed through the whole boat. You never get to keep heat in your joint. So even if it's only 1/4 inch thick, you need some real power on your machine to weld this up. Otherwise, your weld is always going to be cold. You can't even preheat the boat enough.
No, because just
what you want to do, burn up interior and burn up motor mounts and heating it all up, and it's just not happening.
In that respect, we've got a part that has all these configurations of geometry of bracing and gussets and a lap and all that kind of stuff. When you start welding, you got to pay attention. What is your sequence of welding in that area? You want to start out and do the thinner pieces or the stuff that's not exposed, and then later on you might be thinking, I got to go up in settings. I need to make these value changes to do the quality welds.
If you ever build your own computer and you see the heatsink on the CPU, that's exactly what's happening. You have your plate, then you have all your gussets standing up, and every gusset is like another fin on the cooler.
Sure.
It actually just acts like a cooler, sucking all the heat out of your weld joint.
Interesting. One more, or
should we switch to pulse and see the difference? Yeah?
Sure.
Or do you want to do 1/4 inch just to show how 1/4 inch has just the hissing?
Let's do that.
Rather than the crackling? 500 inches a minute and just shy of 25 volts. Yeah, try that. We're manual. Full manual.
Have we done
like
anything?
Any machine, any Miller 211 or whatever could have done what we're doing right now.
Okay, but do we have access to a inductance control? Is there an inductance setting in here in the manual?
Yes, there is.
Okay, and that would benefit.
That could benefit. It could either make a stiffer arc, drive it further in, or it could make a softer arc and make a more fluid, shallower penetrating puddle, better wetting out.
Higher numbers are more wetting, or lower numbers are more
Higher
wetting?
numbers are more wetting, are more softer.
Because some machines, they're different. Minus numbers are numbers are soft, plus numbers are hard and crisp.
Most of the machines I worked with, like domestic manufacturers and stuff, typically that's how they go. Like higher numbers is like a softer arc.
All right. We haven't talked about one particular thing it's a big deal. Contact tip to work distance. What is my stick out supposed to be for aluminum? Because I'm doing my normal thing. I'm doing like 3/8 to a 1/2 inch out.
Yeah, so that's why I want to say you have that gray haze. You don't have that shininess on there. If I would do one, and I would do with a longer stick out, I'd probably have a more shiny weld.
Oh, now I'm interested. Let's do that. So are you talking 3/8, or are you talking from
3/4
to 3/4?
Yeah, 3/4 for sure. So typically what I see, I read a lot of literature on what the wire manufacturer tries to tell me. I found that different wire manufacturers are really doing good things, like in their publications, operating parameters as far as wire speed and voltage. They also tell you flow rates on gas. So when you look at all of this, you can get really good information where you find out how your flow rate is directly tied into, let's say, the amperage. See how shiny this is and doesn't have that gray haze over it? Mm-hmm. I believe that is a function of proper stick out.
And that could be tied to the amount of
gas,
available argon that's
how it
going
flows,
around.
where it goes.
Okay,
yes,
makes sense.
yeah,
makes sense. So I need to learn to use longer stick out in aluminum, just like I would with probably a metal core or flux core.
Exactly, and you know why? It's a spray arc. Every time you have a spray arc, the spray arc needs room to breathe. Like the dual shield is a spray arc. If you do ER70 S6 wire and you weld a hydraulic cylinder base in spray arc with 95.5 gas, you run a longer stick out. Aluminum, you run anything that has spray arc, typically 3/4, give or take, no less than 5/8, no more than an inch, is your stick out, your contact tip to work distance on a spray arc. Where short circuit, you really want to get it in there close, but everything with spray arc needs some breathing room.
Okay, good point. Thank you. A few good, knowledgeable tips and practice, and you can get the results. But not know, where are you going to find this information? You're going to have to dig a while. You won't. It's running into guys like you that know this and have been around and
guys that have welded on over 25 bulk cement tanker trailers, all aluminum, with engine drive, with spool gun, with pulse welders, with whatever, with stick welders out in the storm and in the rain, and just I guess burned like hundreds of rolls of aluminum wire. And I'm not talking about little spool gun rolls, probably thousands of those.
You're talking about 25 pounders.
Yes. Well, there's 16 on aluminum, but yeah. That's really where you do enough of it, and eventually you find out what works and what doesn't. Yeah. You want a chair too?
Nah.
Okay, then I'm just going to sit on the chair.
Yeah, you do the chair.
Should I leave you all these coupons here?
Yeah, I'll leave all the coupons there.
Okay.
Man, I appreciate this. I'm overwhelmed. The material, the background, your expertise, your experience, the settings in the machine. Not to be overwhelmed. It's just a lot to absorb. You need to back off a little bit and let it sink in. I know what I'm doing wrong now. But it's, again, I haven't been on it. I see some things that definite advantage in doing aluminum, and aluminum is one of those things that. Like you're saying, the fabrication, fit up. You do it a couple times and you get used to the properties and overcoming the difficulties, which is the heat dissipation and the oxides and everything else. So.
And when you have the hang of it, vertical up and overhead is so much easier. It just sprays right in the wall, sticks there, doesn't want to run on you. It's not like mild steel.
I've done that. I've done those uphills and think, wow, that's so much easier. You think it'd be tough.
It is so much easier, yes.
It's like, wow, that was made for that. And it just goes in there and you're going, wow, that was super.
Well, I mean, you know where it's coming from? People get told aluminum is so difficult. Like when we argue about what is the most difficult language to learn, often the language comes up like Chinese, like Mandarin. But you know what? There's millions and millions of Chinese kids that get born every year, and they just start talking Mandarin. They're that small, start talking Mandarin, and it's not a big deal to them because nobody told them how difficult it was. And we have these blinders on. Yeah, aluminum is so tough, and you can't do aluminum unless you have a spool gun. You have to AC TIG aluminum. You can't do this. You can't do that.
We stick weld it, don't we?
We stick weld it, yes.
I appreciate you coming in today. Fantastic material. Thank you very much.
Thank you.
So we'll continue on here. We'll go into a series of other wires and other settings and other applications. I'm looking forward to that. Other gases too.
Other gases too, yes.
Okay. Thank you very much. Appreciate you coming in.
Thank you.
Peter Zila, ladies and gentlemen.